So here we are with the next installment of the podcast, and I'm super excited to have you on, Helen. I think I love sharing what my findings and what I see going on out and about when visiting various cities, but also what I learn from people in the industry. And frankly, you've been educating the market, way before I was, and kind of call it maybe a pioneer in that area of the industry. So I'm curious where a lot of that stems from, and if you've been that way from a young age, and kind of if you wanted to carve that path for yourself in the industry.
Oh, interesting question. Well, I guess I've always liked teaching. People ask me what I would do if I wasn't doing the job I'm doing now, and that is one thing that I could have seen myself doing. But typically though, I actually have to try and understand. I have to dig into things to understand them for myself to be able to explain it. So part of what I do is really getting to really understanding myself, and then I figure, okay, well then maybe I could just write that down and share it, because sometimes I have these epiphanies and I go, oh, well, it took me a while to figure that out. I mean, maybe other people have those same I have these same this would help address and give other people some epiphanies or light bulb moments, as they say.
Yeah, well, I also find that a lot of people like to hyper focus on their niche, whether they're in
Hmm.
sealants or they're in float glass or they're IGU fabricators or they're, on the aluminum fenestration side. But you've seemed to expand it way beyond. I mean, I know you're with obviously given the background Technoform, which dives into a lot of different areas, but to really understand the impact not only of a thermal break on a window assembly, but also a spacer and how
Hmm.
that impacts the IG unit coupled with everything around it. To be able to speak to all these end users, you have to look at it from a holistic standpoint. So um, that had to have been intentional on your part, because I'd imagine there's a lot of people either within the company or in that side of the industry that are hyper focused and knowledgeable in that area, but can't really understand some of those issues on the other side.
Yeah, I mean, I try to put things into context. People have I think some people say, you always have to ask the question, well, so what, right? So, okay, so what? And so that, keep asking that, and then it drives you to have a broader and broader perspective. And I think it's really helped being part of the Facade Tectonics Institute, and you meet so many people from the whole breadth of the value chain, from owners, architects, obviously, really smart engineers and building scientists, and through to the general contractors and glazing contractors. And so you build up a really interesting map of different perspectives that helps provide that kind of perspective. So you can start to see everybody's, where everyone sits in everyone's perspectives, and it helps answer that question. So what?
Yeah, I've been having more and more conversations on the podcast about differences in the European market versus
Mhm.
domestically here, but people from overseas look at the American market and they want to put us in this one bucket. But here alone, I mean, I remember you initially made the comment, does U value matter in a warmer climate? And so when I spent time in Florida, solar heat gain governs everything. And then I go, an hour north, I'm up in Boston, and new construction buildings are designed around passive house principles. So
Mhm.
such a disconnect. And maybe it is climate specific. So the real answer is that we should be designing to the specific climate. And I would imagine that makes it tough to govern nationwide energy codes because I mean we do have the different climate zones and how and what is applicable, but it becomes challenging, especially to find solutions that are applicable everywhere. I mean, a question for you is, if there's a place for insulated glass in Florida, and I asked somebody this yesterday, you might consider upgrading from a standalone laminated unit to
Mhm.
insulated,
Mhm.
but all of a sudden, what does that mean for the lifespan of the unit? So you might
Mhm.
be improving the overall U value, 10, 15%. Um, but all of a sudden now, I don't know what that maintenance period looks like over time.
Yeah, well, it's interesting because in order to even hit the solar heat gain values, you have to use an insulating glass in Florida. So it's not even a matter of U factor, it's actually getting the solar heat gain coefficient because you need to be able, because for the solar heat gain coefficient, it's not just the directly transmitted, it's the absorbed and re-radiated. And so you really need to, have a insulating glass unit to support that, because you really need a low E on that surface too.
Mm-hmm.
So the other thing about, you mentioned you factor in those hot climates. We actually did a study and actually measured the temperature on the room side of the metal of several different framing systems, from a non-thermally broken system that, historically you'd see in Miami, to one that has very wide thermal barriers. And the temperature that you had on the non-thermally broken one on the room side was enough to burn you. Yeah, I mean, it's
wow.
And it's a solar heat gain issue, but it's also a conductance issue, because the frame's going to absorb solar energy on the outside, and that solar energy is going to go somewhere. And if there's no thermal barrier that separates the outside from the inside, heat's going to travel unhindered to the room side, and you're going to get a cooker on the inside.
So I think from an office space standpoint, you would think it's unbearable during the day, and so a lot of times they'll have the shades up, or they're just pumping air conditioning. But in a multifamily application, I'm in New York, and at night in the winter, if you're in an older construction building and you're close to the wall, it's cold and you can feel the difference. So, I wonder in Florida, with people staying at home, if it became so unbearable in their living space that all of a sudden they picked up on some of these trends, or what it actually means to have a higher performing envelope.
Yeah, I mean, I wonder. I mean, the thing is, I think there are a high performing envelope. There are some traits that are the same no matter what climate zone you're in. I mean, having a tight envelope with low air leakage. I mean, if you want to keep heat in or you want to keep heat out, but either way, you want to stop it transferring across the envelope. So low air leakage is important really wherever you are. One would also say that reducing thermal bridging too is important, whether you happen to be wanting to keep heat in or heat out, because heat still flows from hot to cold. So there are some similarities. Obviously, you have different heat gains that you have to manage, and that's obviously that's why you historically, before we could have HVAC, you had very climate specific designs.
Right.
The designs of the buildings in Phoenix would be very different to the buildings up here in Cleveland or in New York, because they had to be designed to be climate specific, because there was no mechanical HVAC systems available.
So because you're so focused on the edge of glass, I don't know how often you're reading specifications or getting your hands on early documents, but do you still find that there's this major disconnect between people designing around a center of glass values instead of analyzing the whole assembly?
Oh yeah. I mean, this has been a soapbox that I've been on for a while, ever since I actually moved to Technoform, is to get people to realize there's a big difference between the center of glass and the whole assembly. I mean, even in specifications now, I see spacers are ignored. And if you ignore spacer, you're going to get an aluminum, cheap aluminum system, and you're going to have issues of maybe condensation at the edge and lower thermal performance. And the disconnect, I don't think, often people are looking at the window specification and the glass specification and making sure they're consistent with each other. Because you may have an assembly U factor on one part of the specification, and then specify an IGU makeup that's not consistent.
But looking at the difference in cost, though, I mean, the premium to go from aluminum to stainless steel, and then even stainless steel to warm edge, you're talking like cents or pennies. Like it's almost negligible. So do you think it's just overlooked? I mean, it can't be a cost issue. I've said on an episode before, I once had a general contractor ask me to give a deduct to go from argon to air in the cavity. And I'm like, I don't even know if they'll offer that. Like, I think argon is just the standard.
Right.
So, they get so caught up in these little things that aren't making really the great impact.
Yeah, I think it depends. I think it depends where you are. I mean, in some areas of the country where warm edge is ubiquitous and it's normal, and I'd say, so maybe in the Northeast, but certainly when you get into Canada, it's more normal. People don't upcharge for it. But in places, maybe in the middle of the country, where codes aren't pushing it, it's a special order. And so, there is an upcharge for it. And depending on where you are, it will depend on the upcharge. Some don't, but some do. And, when you get down to it, the actual, as you say, the incremental cost is really pennies. When you look at the whole unit and the price per square foot, it's negligible. So I think when it comes to, whether it gets spec'd or not is whether it gets used. And if the architects know about it, then they're likely going to specify it. So it comes down to, at least in my mind, an education of the architects.
I find a lot of times the only really thing they care about with the edge is the aesthetic. They want to know what the color of your spacer is going to be. And other than that, just hit my values that my mechanical engineers, dictating us to hit. But is a lot of your time and focus on heating dominated climates, or call it, New York and above, going up to Boston and the Seattle and Canada?
I'd say to some extent, but also moving down into the south, into the middle and the south, because that's where, there is significant opportunity for education and also need. And you also, you're going to go where the codes are driving performance, because that's where you can solve a problem. And then you'll go elsewhere when it's when the opportunity is to educate architects. Even if the codes aren't driving, it's a really easy way. The warm edge is a really easy way to improve the thermal performance without busting your budget.
So I do want to pick your brain on a topic that came up recently with my friend Spencer Colhane. I'll give him a shout out and say he mentioned you, in that a lot of the Europeans design their IG units to have almost a toggle system so that the spacer can be mechanically retained. And that was a first that I really dug into, that type of system design. Why do you think that method hasn't been adopted here?
Well, so the toggle system is for a certain design of curtain wall, right? So I think it makes it look more seamless. I think in Europe they are more used to doing it, and there's certainly more of a emphasis on making sure you've got enough silicone, making sure that you've got the engineering right around the edge, so that you've got enough of those clips that are held in effectively, have the right amount of silicone, because this is a structurally glazed application. So this is really important that you get it right. So it might be just aligned with a risk tolerance. I would say though that there is, I believe there's at least one manufacturer in the US that has a toggle system. I don't know how often it's used though, but it typically isn't business as usual here for IG fabricators.
And does it have anything to do with certain jurisdictions not allowing for structural, when I say structural glazing, meaning having a glass, a structural silicone bond being the only thing adhering back to the frame and withstanding that lateral load, and jurisdictions requiring some type of mechanical retention? Have you heard of anything like that?
I think in Europe, there's actually less tolerance for four-sided structural glazing. That's my understanding. And that often two-sided is the norm because of the risk aversion to four-sided.
Interesting.
I have not
have
heard
we
that.
seen any of the ramifications around that? I mean, I think I ask people this, and I think it's a sensitive topic that some people don't want to really address, but I've witnessed structural silicone bite failure, and maybe you do deglazing and see a lack of adhesion, but I don't know. You walk around the city like New York City, and there's just so many four-sided structurally glazed unitized curtain walls. And, I think a lot of the sealant manufacturers will stand behind it.
Silicone is an amazing material. And I think if you talk to the guys from Dow, I mean, they have existence proof of four-sided structural. I think last time I heard is at least 50 years old. It might be useful to get, John Kimberline on one of your on your podcasts. Again, I'm not an expert on silicone. It's just obviously they do a lot of good engineering and quality control around structural glazing. I mean, obviously it's really important to get it right. So, and also you have to design the IG right too, because not only do you have to get the silicone width right on attaching the IG to the aluminum, but you've also got to get the bite right in the IG itself.
I don't think there's enough of that IG fabricator collaboration with the unitizer or window manufacturer. It just seems, a lot of the truth is the IG fabricator should be commenting on and reviewing the design to see if they'll warranty it, if there's any concerns about water ponding or pooling, or like you said, the structural integrity. So it is strange to me to think that they kind of sell it just like it's a kit of parts, and then you say whatever you guys do with it, and then down the line, if there's some type of failure, maybe they diagnose a detail is wrong. But it's such a high risk liability item.
Right, and I think the IG fabricators are relying on the structural engineer to tell them what the silicone bite is, how much silicone they need to put in it. They may do, and they probably do a check just to confirm that it makes sense. But at the end of the day, where does the responsibility lie for the design? Is it with the IG manufacturer who really doesn't have the big picture?
Right.
And probably not. I mean, it really needs to be whoever's designing the system and making sure that everything is working together appropriately to all the loads. And not all IG manufacturers have the structural capabilities in-house to do those analyses.
Yeah, for sure. So past the edge of glass now, looking at the thermal breaks, I can appreciate some of the nuance now, digging into the German world of passive house design. And it's funny, we always face this battle in New York, that New York is all about sight lines. The architects want what they want. So Spencer makes this Spencer makes this joke that sometimes some of the windows look like door frames, and but that's the norm in other places. So it's crazy to me that, like I said, I go up to Boston, and passive house is the norm now in new construction. So when it comes to these more demanding requirements, you can't ignore, obviously you can't ignore the frames. So these just bigger, more complex, deeper struts are becoming more commonplace. And I'd imagine now you have to have that offering from Technoform standpoint to more suppliers.
Yeah, I mean, we've had that offering for many years. In fact, we show this timeline of product development of thermal barriers from like the 1970s through today. And, you can see on that timeline where Europe is, you can see where Canada is, and you can see where the US is. And the US has, been all the way down, still in the 70s, 80s. We have the technology, and certainly we work with window manufacturers to create increasingly higher performance systems, and that is obviously a trend. I would say though that a shout out to Warsaw Window and Wall Systems. They went out and did some benchmarking in Europe, looked at the thermal performance achieved there, and they came back and designed their own system that actually could go from relatively medium performance up to really, really high performance, better than R5. And they did it while preserving some narrower sightlines. So you could, they obviously knew that having European systems was not necessarily going to be a good fit to the US market because of the slimmer sightlines. And so, we're really pretty impressed with that system. And they use the same internal external mullions with different size thermal barriers to give you a whole range of performance. So you don't have to have different mullions from your in your good, better, best. You have the same extrusions, I should say, not mullions. And they have the same extrusions on the outside and the inside. They just change the thermal barrier type to give you higher performance.
So just change the depth, because a lot of times people don't really care about depth. They just care about sightline.
Yeah, right.
And that conversation, or what you just said about how we have a lot of these systems already in place. I know you have experience on the dynamic glazing side. And another question or kind of topic I bring up a lot and want to hear your opinion on is how people are trying to introduce all these new technologies and materials and make UPVC window wall work in high-rise construction and talk about dynamic glazing or vacuum glazing. And it's one thing to say this is going to be an exception of a job and we're trying to achieve something well beyond the norm, but to think we have more stringent codes and we don't already have these systems tested and implemented is short-sighted thinking. I don't know the right way of saying it, but it's like we have so many examples of high performance envelopes, even utilizing a typical double glazed unit with maybe multiple coatings or maybe just proper detailing and implementation of an air barrier and tight compression seal windows and just execution of details, that it's like we're looking for almost like the quick fix or something else to introduce, and it's not needed.
That's actually a really good point. I think if you talk to a lot of consultants, they would say, we already have pretty good what they call clear field. So good opaque panel, good opaque and good transparent, fenestration performance. But what we're missing is all the thermal bridging and the air leakage around the interfaces. And we have not spent enough time plugging those holes. It's kind of, I think about a dam, right? If you've got a few massive holes in the dam, it doesn't matter if you make it wider or taller, it's still leaking, right?
Yep.
So you've got to figure out how to fix the holes in the dam first. So thermal bridging, really big issue, and around windows, right? I mean, the position of the windows in the opening, and to make sure that you have the continuous air barrier, continuous thermal plane. So, I think you're absolutely right. We haven't dealt with those details yet. And it comes to also in commissioning. Have we really got the quality control process down right? Are we doing enough commissioning? Are we doing enough quality control through the construction process to make sure our air leakage is under control, or make sure that we've dealt with all those thermal bridging issues? And then we can start making the windows better, or
maybe introduce triple glazing at that point, but we don't need to start with it potentially. And that's what I really, not saying you have to go for passive house certification, but just adopting some of those principles. It's like, if you have to do your blower door testing at the end and you have to stay accountable to it, you're not going to cut corners. It's just all of a sudden you're going to pay that extra money to have a facade superintendent on site, or to have that quality control program. And part of the issue is that we're following, NFRC guidelines that were designed for the residential market. And so there's so many exclusions and items that don't address on-site conditions as you're describing, whether it's receptors or perimeter conditions. And the passive house and European model takes into account the as-built conditions. So all of a sudden there's no cutting corners. And I think after having the conversation so many times, what the harsh reality or truth is that unless it's enforced by code, and rather forget just code, unless it's enforced, it's not going to happen.
That's right. Yep. And I think so it's got to be required by code, and then it's got to be enforced. And, if you look at Massachusetts, they've done some really pretty interesting things. Now, obviously they've allowed passive house as an alternate compliance route, which is great. But their main code, they just did some simple things, like they required thermal bridge mitigation. They've required, they reduced the air leakage requirements. They haven't, realistically, they didn't really change the prescriptive requirements for windows much. They did a bit, but by having a backstop, an envelope backstop, and some specific requirements when you want to use window wall or curtain wall, they are really ratcheting down the U factor that you have to get to if you want to use curtain wall and window wall, anything with a spandrel.
Well, the interesting thing is with the Massachusetts stretch code, I'm finding that it's not required in a lot of jurisdictions, but a lot of them are opting in when you get outside of the greater Boston region. And so maybe there is a little bit of like a peer pressure factor of it, which we can learn from. But it's good you just mentioned the backstop, because I know you've seen that in places like Seattle and an attempt to get it in New York. And I know a lot right now are struggling in Boston to interpret the code, because there's a difference between measuring and reporting thermal bridging versus actually having to address it and who's accountable for it. So what are some of the, in a city like Seattle that's now had it in place for a few years, what are some of the results that you've seen?
So it's interesting. So I was actually talking to Dwayne Jonlin, who's the City of Seattle code official. He was helping me. We're actually doing a case study on various jurisdictions that have been moving the needle. And he said, typically not many buildings have a problem meeting the backstop. Schools, those kind of buildings are fine. The ones where he's seen the biggest challenges, and it's generally related to where you want to use curtain wall, and they see it with a multi-family residential, the bigger residential buildings, and larger office buildings, and there they've seen, you can still use curtain wall, you just need to be a bit more judicious with it, and the window to wall ratio is, I forget exactly the number he said that it typically limiting to, but maybe around 50 to 60%, which, if you think about it, a floor to ceiling glass in a building is maybe 70% window to wall ratio, because you've got,
when you say window to wall ratio, I think some people are going to misinterpret by not understanding that spandrel glass is wall area.
Exactly.
So there's still a lot of ways to incorporate opaque materiality and still go with a unitized curtain wall.
Exactly. Absolutely. And you can still have your glassy look. You just have to be a little bit more judicious with, where it goes. So again, from my understanding, in Seattle, which has a 10%, what we call a 10% UA backstop, which means you can be 10% worse than the prescriptive envelope. So you still have some ability to trade off. They're not seeing huge impact on, the building designs per se. They are seeing, though, because their codes have been increasingly getting more and more stringent, they've actually seen, even with an increase in construction over the last few years, they're actually seeing a reduction in energy use in the city.
Wow.
So they're seeing some impact of their more stringent codes.
I want to dig into that for a second. So, because I asked a couple friends from the SGH team in Boston what they, because a lot of times they are opining on the facade performance with the architect and asking, what have you seen in terms of design changes or preferences from an aesthetic standpoint? And they said not a lot. More attention to detail, but it's not like we're completely changing system types. So what you just said about we're still being able to implement unitized curtain wall, just more intentionality around detailing, and with that, they're seeing an overall reduction in overall energy usage.
Right, because of the general reduction, the increase in stringency of the code. Now, I should say, though, the backstop in Seattle is less stringent, probably significantly less stringent than in Massachusetts. So Massachusetts used to have a 0% backstop, like in the 2020s, which meant that your envelope had to be the same area weighted U factor as prescriptive. This latest stretch code has ratcheted that down some more, because the backstop is now related to the vertical envelope only and not the roof. So you can't trade off roof and foundations. It's just related to the envelope. And if you want to use any type of glazed wall, then there's a secondary limit to the UA.
So what do you think the real impact is of that? And I was going to say, just put on an R200 roof, and then you can have all, vision curtain
so they don't
wall,
allow you. Yeah.
But the point is that you're saying, if you were to go that route and just do a bunch of trade-offs, you're still losing so much energy or heat loss through the wall that you're going to have to compensate for it somehow via mechanical conditioning or heating or whatever it might be.
Well, I guess what I'm saying
essentially is getting at the conclusion that the trade-off method isn't effective.
Yeah, I mean, basically, Massachusetts has really limited the ability to trade off with mechanical systems. And I mean, my heard the same things from the SGH folks and the RDH folks in Boston. They say, at the moment, they're not seeing a massive change in design. Primarily, they're saying is because there's a lot of things in the pipeline that were already designed that they have to figure out how to meet code. What they are seeing is more judicious use of window wall and curtain wall. And it's all, one of the biggest issues is making spandrel work. And so, I think that's where our industry has some opportunity, is to really figure out how to improve spandrel performance. And, as we move away from the typical two-dimensional spandrel performance, which really overestimates the performance, that's going to make the challenge even more significant, because spandrel is going to look worse in the future, because the performance will likely get derated from the current way the performance is estimated.
So what would you respond to somebody if they were to say how would you respond to somebody if they were to say the only way you make a highly glazed unitized curtain wall work in some of these cities is with triple glazing?
I would say that's probably one way to do it. It depends on how much curtain wall you're going to use, and you're going to have to use it judiciously. I mean, it's going to be hard to use it on all four sides of the building without having to do something like that, and probably more. Now, of course, you don't have to use a triple pane. I mean, you could use a hybrid VIG that could get you there too. If you wanted to that's probably going to be the more expensive option. But I always say to people, like, you have to start on the edge first with a really good frame, an edge of glass. Because again, going back to that dam, you can do wonderful things to the center of glass, but if you've got the super highway of heat flowing through your frame, your assembly value is not going to work. So start from the frame, edge of glass, and then and look at the transparent area. I will say, though, also to bear in mind, in Massachusetts, you are allowed to use the assembly performance values based on the actual size. So making the glass size bigger tends to help. So there are some strategies on, in terms of how you design your curtain wall. So probably you don't want to have 2-foot modules, right? You're going to want to have bigger modules.
Yeah. And then the balance especially in the window replacement world, just because there's so much opportunity there. I like sharing details online. They're not always perfect. And people love picking them apart. But the reality is, when you're working within confinements and certain constraints, you're limited. You're limited to performance. And I think with new construction, you can draw a blank canvas and you can, design perfection. But, within replacement applications, there's always going to have to be compromises. And understanding that ultimately we have to find a way to incentivize or motivate building owners to upgrade their buildings. And if we make it either code prohibitive or just cost prohibitive, they're just going to leave it as is. So we always talk about how the bigger opportunity at hand is addressing the existing infrastructure, but everybody has to win at the end of the day.
Yeah, and that's a really big deal, the existing infrastructure. I've been working for the last year on a project that's been funded by the Department of Energy through the Facade Tectonics Institute to really understand the barriers to the implementation of higher performance facades, both in new construction and retrofit. Digging into the retrofit, I mean, there's lots of barriers for new construction for using high performance systems. But the barriers to putting higher performance facades in new construction is huge. I mean, I never realized the challenges with old facades, not understanding the conditions, and the fact you don't even know what you're going to get until you actually start the project. And so the risk of additional costs because the anchors aren't strong enough, or even if you wanted to put new anchors in, you maybe can't because you'll be running into rebar. Those kind of things that, increase risk and cost before you've even considered the cost of the fenestration and the facade system itself. It is almost a non-starter. So when you think about how to address that, you've either got to do some amazing incentives to address, doing some surveys up front, paying for these surveys, and something to reduce the impact of the upfront cost and risk relative to the payback period.
Frankly, a building owner, I think the payback, the energy reduction in utility costs is sort of a
Mhm.
secondary benefit, but they can't
Mhm.
look at it because the inherent costs, whether it's 8 million, 10 million, $12 million,
Yeah.
they'll get their payback in 50 years.
Yeah.
It just
Yeah.
doesn't make sense from that standpoint. There has to be some other motive, whether it's attracting new tenants or completely revamping their building to a new use.
Right. Yeah, it's got to be something about being able to. I mean, at the end of the day, the payback, it can't be on energy because it's too small. It has to be around increased lease rates, or somebody actually finds that they can actually lease that building. One of the things that we've been talking about is we need people to care about their facades like they care about their phones, right? We
Yep.
we need our facades or our windows to be thought of in the same way as people think about marble countertops. That's what we need. People need to care about the quality of the windows that are going into their buildings, whether they happen to be the owner or they happen to be the tenant. And owners won't do anything unless the tenants are asking for it in that kind of relationship. If tenants wanted more than just floor to ceiling windows, if they wanted floor to ceiling windows and they wanted to be able to sit within 2 feet of it comfortably, that would change the conversation, or the potentially the equation that the developer is looking at.
Yeah. All right. Last one for you. And some of the VIG folks are not going to like this one. So, there's the VIG community right now is on a quest to try to salvage the single pane retrofit market and leave the existing frames in place and just replace single pane glass. And I see the merit in historically sensitive architecture, in conditions where the underlying substructure can't handle the weight of an insulated unit, or there would just be you'd rip out the frames and expose asbestos and have all kinds of issues. Fine, there are certain challenges that we have to overcome. But what you were just describing about the dam, I mean,
yeah, you got the super highway of heat coming through non-thermally broken frames, and that's the challenge, right?
You're putting a super performer around all these heat sinks.
That's right. So you can't. I mean, it will help, but it's not going to solve the problem. You're going to have very cold frames that you'll have to sit next to, and well, one of the things that we could talk about though is the secondary glazing, and this is being pushed by the Department of Energy just because it addresses all the disruption, the risk, and the cost of ripping out your whole facade.
Sure.
You can put in either an exterior or an interior secondary glazing. You still have some issues if you're not insulating the frame though, so you have to be careful about that. And there are still some challenges with that, but it's certainly there's not as good as ripping the whole facade out and putting something on new, for sure. But the question is it sufficient? Is it good enough? If you can do it over 10 times or 100 times the number of buildings, does it get you way more benefit than maybe only doing 10 full retrofits?
Right. Agreed. All right. This was a lot of fun, Helen. I would love to have you again. What are some things that you're working on, or where people can find you? I know you have your blog, so if you want to talk about that and what else you're focused on right now.
Yeah, sure. So my blog every month, always looking for new things to talk about. In fact, looking at next month, talking about some of the competitive issues with Europe, and how we can, increase the capacity in our local market to address that. I do have a column every 2 months too in US Glass, which I pick a topic. I've been doing a back to basics, just looking at particular aspects of Windows. So yeah, and the other thing I just mentioned that I'm working on right now is this project with Facade Tectonics Institute. We're just actually going to publish a report on the barriers and potential ways to address why we can't get high performance fenestration in buildings. We'll be publishing it in the next couple of weeks, so look out for that. Probably we'll start writing some blogs on some of the findings in that. It's been eye-opening, but that just gives us the opportunity to try and address the barriers and really increase the capacity for high performance in our buildings.
Wonderful. So you can find Helen on US Glass and Facade Tectonics. Thank you so much for coming on. I had a lot of fun.
Oh, well, thank you, Adrian. It's been a pleasure. Thank you so much
Awesome.
for
We'll talk
inviting
soon.
me. Yeah, thank you.
Bye.